If you visit the Museum of Contemporary Art in Hiroshima these days, you will find an exhibition containing a large installation with Nixie tubes. To make this project happen, we had to develop more powerful tools, get more space and grow the team. It was the most challenging project we've made, and this is the story. So, in April 2020, I got a phone call from an unknown number. The man on the other side described a very unusual Nixie tube installation that he would like to realize. It was supposed to be a 5 times 5 meters large wall covered with giant Nixie tubes displaying a specific animation. No such Nixie tube ever existed, so we knew we would have to develop our own. That's exactly what we live for here in our Nixie tube laboratory. The project promised a lot of engineering fun, and I loved it from the first moment. The man turned out to be Alfredo Jaar, and a quick Google search on his work suggested that this time we will not use Nixie tubes only for their beauty, but they will become a part of something more meaningful. Alfredo Jaar is a famous artist, architect and filmmaker known for his impactful art and storytelling. He was born in Santiago, Chile in 1956. His work focuses on important global issues like social problems and human rights violations. Through his art, he wants to make people think, feel empathy and engage with the world's most critical challenges. In 2019, Alfredo Jaar was awarded with the Hiroshima Art Prize, which is given by Hiroshima City to artists who spread the spirit of Hiroshima through the world. And the spirit of Hiroshima in this context means contribution to world peace through art. In addition to the prize awarded, Alfredo Jaar was granted the opportunity of having a solo exhibition in the Hiroshima Museum of Contemporary Art. And one of the works created by Alfredo Jaar was called Umashimenkana. At this moment it was still in the phase of ideas and description, and our task was to take the sketches, ideas and description and turn it into a physical object. I'm eager to jump straight to the technical things, but to get a full picture of the artwork and of the project, let Alfredo Jaar explain Umashimenkana work.
I've created this work called Umashimenkana for the Hiroshima Museum of Contemporary Art. Umashimenkana is based on a poem by Kurihara Sadako. Kurihara Sadako was a poet and an anti-nuclear activist. She was living in Hiroshima when the first nuclear bomb was detonated above the city. That same day, her neighbor gave birth to a child, and she helped the neighbor. And after helping her, she wrote this poem, which means, "We shall bring forth new life." So she wanted to suggest that even in the middle of the horror, we should always bring forth new life. And that's what she does in this poem.
Sadako Kurihara passed away in 2005, but thanks to the work of Hiroshima Peace Memorial Museum, we can still listen to her reading the Umashimenkana poem.
ウマシメンカナ、壊れたビルディングの地下室の夜だった。原子爆弾の負傷者たちはろうそく一本ない暗い地下室をうずめていっぱいだった。生臭い血の匂い、刺繍、汗臭い一息でうめき声、その中から不思議な声が聞こえてきた。赤ん坊が生まれるというのだ。
The full length of the poem is available at the link under the video.
So with this work, I wanted to convey two things. First, the horror of the hundreds of thousands of victims of the first nuclear bomb in history, but I also wanted to incorporate the hope that we shall always bring forth new life. So specifically in this work, we have numbers. We have plenty of numbers. And then we display the numbers in sequence from 9 to 1. And then suddenly we reach 0. And there's a rain of zeros. This rain of zeros symbolizes the death. The thousands of deaths of Hiroshima's nuclear bombing. That lasts for 1 minute. Every zero is a death. And at the end of this 1 minute reign, we display this extraordinary old Japanese word, Umashimenkana. We shall bring forth new life. So that is the end of the work with this very hopeful phrase.
So that's it, that was the vision of the artist, and our task was to develop the new large Nixie tube, make 121 of them, bring it to Japan and install it there. The museum will prepare a large black room with 121 holes for mounting the Nixie tubes and enough room in the back so we can install the Nixie tubes from behind, hiding all the electronics and cables. There will be 114 Nixie tubes capable of displaying digits 0 to 9 and additional 7 tubes in the center, each of them having a different Japanese character. So, as I mentioned, Alfredo's exhibition was planned for October 2020. We had roughly 6 months to develop and manufacture Umashimenkana. For this reason, we decided to use materials and manufacturing techniques that we know and led very little for development. A shape of an old and proven CRT screens was taken, a narrow neck with feed-throughs and a wider section with the internal system with digits. The glass would be divided to 3 sections. First, the internal system would be placed into main envelope, then a window would be sealed to the envelope, and as a window we would use an off-the-shelf watch glass. Finally, third glass component stem would be sealed to the neck, completing the glass body. Inside the tube we would have 10 numerical cathodes, and a few tubes would have also an 11th cathode Japanese character for the Umashimenkana sentence. The digit stack would be supported by a rigid anode cup that will serve as the main structural part. We would have anode grid over the digits to fully enclose the cathodes with uniform electrical field. Finally, the glass window would be sealed while the internal system is already inside, because the sealed joint would reach some 1000 degrees of Celsius during the sealing process. We had to protect the metal parts from overheating and oxidizing. The plan was to use nitrogen as a forming gas that would displace all oxygen from air from the tube, so no oxidizing could happen. The first task was to prove the design of the glass, so I ordered the watch glasses and the envelopes, and they arrived quite quickly. Then I tried to seal the window to the envelope with our existing equipment that we use for sealing the R tubes. The first attempts were not very successful because the burner doesn't produce enough heat. So I found an old carriage burner that we got with a lathe and hooked it up, and finally made the first successful seal. It took a lot of time, it was clumsy setup, and the burner made a lot of loud flashbacks, but it worked. Another task was to develop the digits. All the old Nixie tubes in the past used just a single line of the contour to make the Nixie tube as efficient as possible. This time, because it was an object of art, we wanted to make things different, so we used the contour of the digit. This makes the digits more proportional and better readable from the distance. One of the obstacles that I didn't know how to solve was how to connect the digit with the stem in the bottom so that the connecting wire doesn't glow. I knew that the solution exists because there are many old Nixie tubes with different type of insulation on that part of the wire, and it works, but I just didn't know what kind of composition, what kind of wire is there. So I tried a lot of different techniques that I had in my workshop from the previous experiments. I tried to coat the wire with a thin glass coating, I tried enamel coating, different techniques how to oxidize the wire. I tried wire coated with borax, and finally I tried to source filaments coated with oxide coating from a company that specializes to make filaments. Such a solution was used in old Czech Nixie tubes, but the price for these was astronomical. I was slowly running out of ideas and quickly out of time. And what happened, under one of the videos in the comment section, Ben Krasnov, aka Applied Science, commented, and he suggested to use a wire called Cerama wire. It's a brand name of a wire produced by a company in the United States, and this is a perfect solution for us. It's a thin nickel wire coated with a ceramic coating, which is very flexible. It withstands temperatures over 1000 degrees of Celsius, and it's suitable for vacuum. So perfect, exact fit for us. That's one of my favorite things on YouTube, because if you share something, you always get much more from the community and from the people around you. The Cerama wire is not something that would be immediately available. You need to wait 8 weeks for it. So we had 8 weeks to get all the other parts that we needed for assembly of the first prototype. And so we ordered the ceramic parts. We have very good supplier for the ceramic parts. They are very fast and reliable, so this was easy. And we also meanwhile received all the other parts for the internal system. The last remaining part was the most important structural element. It was the anode cap that holds all the parts on it. It's very important for it to be quite lightweight, because if you ship it and it's too heavy and the tube receives an impact on it, it will travel and damage the internal parts inside. And if it is too lightweight and not rigid enough, then it would flex, and if the bottom flexes, also the digits will be flexing and touching each other, which means that they will glow together or short to the anode, which is the worst situation. So we needed a rigid stamped part. We tried to first develop some technique ourselves, how to bend it with simple press and 3D printed jigs. I thought that maybe if we have the ability of designing and doing some stem parts in-house, it would be great. It would help us to design better vacuum tubes, but it turned out that it's very difficult. So I asked a local supplier who makes a small stem parts to make a bigger one for us. After a couple of weeks, they had something which was not perfect, but was good enough for assembly of the first prototype. So after 2 months, in August, I could finally put everything what we were, developing a couple of months, put together and do a first test. Building of the first prototype went quite well, with the exception of the the glass. There was too much stress accumulated in the front window, and overnight it broke. So I couldn't finish the vacuum and the filling part and test how it works. And anyway, I had roughly 1 month to finish the project and ship it. So there was not enough time to make it. I started to make another prototype, and soon after this I received a call from Alfredo that the exhibition has to be postponed because there was just the pandemic unfolding and it affected the schedule of museum, and the museum had to postpone Alfredo's exhibition to the time where they had already planned a large renovation project. So they had to postpone it even more by 3 years to summer 2023. So this was a huge strike of luck, and this saved the project. So in the past months we did some progress, but we needed to speed up the development because it was all going too slow. One of the reasons was that we lacked space. The current workshop was too small and too messy. I spent like half of the time searching for tools instead of doing the actual work. The same problem was a lab, because we didn't have a lab, so I did all the experiments in the washing room and I messed it up. I had to clean it up, and also whatever I did was very improvised and not very safe. So there were still 2 free rooms available at the castle for rent. This is the place we are located. So we took them and turned them into a workshop and a laboratory. For the new workshop we got a new lathe. The old one got broken completely. Then we needed to increase power of our burners. We needed more oxygen, so we built an oxygen source. Normally you would have cylinders with oxygen, but it's very difficult to move them around, and we don't have a loading port, so we decided that we want to have an oxygen concentrator. As usual, it took longer to build it and to make it reliable, but now it works perfectly and it never runs out of oxygen. First H-tube is finished, so let's connect it to the power supply. And the first glow of the H-tube. Oh yes, number 1. Finally we had our first working H-tube. It was not perfect, there was just a few digits working, but the most important thing was that the glass was holding up, the digits were glowing, and we had to start working on the details. So the first thing was the anode cap. We abandoned the idea of doing it ourselves and asked a professional company. They redesigned the part slightly. They added some details to improve the rigidity of the part, change the thickness, material, and build the stamping die. And in 4 weeks we got the box with the first parts, and they were absolutely perfect. We started working on multiple H-tubes at once. This was our first batch. This time the problem was glass. Like 80% of the tubes broke because the stress in the glass in the front window was too high. And we solved it with a large gas air burner that heats up the glass over 560 degrees of Celsius, which is the point where the stress in the glass is relieved, and then slowly cooling it down. H-tube number 1, number 2, 3 and 4, 11, and finally 8, 9 and 10 are already shining on the wall. After a few months of practicing and some 100 tubes sealed, the glass working operation got to some 100% success rate. But this was not the last problem. The digits were still turning brown due to the heat during the sealing operation. The dark color means there is a layer of oxides, and the layer of oxides makes the glow on the digits uneven. And if you leave the layer of oxides on the digits, the situation will only get worse over time. So it was absolutely necessary to get rid of the dark layer. At this time we were using nitrogen to displace or oxygen from the tube during the sealing, but it didn't work. So we tried again different ways how to fix that situation. One of them was to switch from pure nitrogen to nitrogen-hydrogen mix. We hope that we will create a reducing atmosphere inside the tube, and the hydrogen will trap the remaining oxygen inside. But there was no change, so we challenged the very basic idea of purging the tube. We took dry ice and used the fog generated by dry ice to visually model how it flows through the tube. We saw that the purging gas can get to every corner of the tube, so the idea was correct. In the previous attempts, we shot the purging gas right in the moment when we stick the front window to the main envelope, because I thought that at this moment no more oxygen from the atmosphere outside of the tube can enter the tube. And also we needed to shut the gas because it created overpressure inside the tube, and that overpressure, when you melted the seal, it tended to create bubbles on it. In the end we found a solution that prevented the oxidation completely, and the solution was to just keep the flow of the purging gas on for the whole sealing process. We only had to add the pressure relief on the purging system to prevent creation of the bubbles, and suddenly we got H-tubes completely free of the oxidation on the cathodes. That was a huge progress and we could move on. So now we had the problem with oxidation solved, so we could start a slow production of the H-tubes, and another problem soon appeared in the very last stage of the manufacturing, which is called burn-in process. And at this process you take a fresh new tube, you run it at slightly higher current to stabilize its electrical parameters, and at the end of this process you test them to see if the tube reached these desired parameters, to see if it is good. And the problem was that at the beginning of the burn-in process there was a lot of arcs created between the wires in the H-tube, and these arcs were destroying the electronics of the burn-in machine. So Radim had to find a way how to modify the burn-in machine so it survives these arcs. After a few attempts, Radim found a solution and we could finally start the burn-in process for the whole batches of the H-tubes. In March we had the installation finished, including all the parts. We just didn't have much spare tubes. We had only 10 spare tubes or so, and we decided to pack it and to ship it because we still had some 3 months to the installation, and the idea was that it will take 6 weeks for the package to arrive to the museum. Once it arrives, the museum staff will unpack it and we will see if there is any damage, and in case there is, we'll be able to prepare replacements and ship them by air, and they will arrive in these remaining 6 weeks before we are coming, and we will have everything inspected and prepared for the installation. In the following weeks, I was tracking the movement of the ship with our pallet, and it was moving very slowly, and in 6 weeks it arrived to Malaysia. And I found that even that we ordered door-to-door shipping, the shipper gave us estimated time of arrival to Port Klang, which was in Malaysia. We thought that it's already in Japan, but it was in Malaysia. So the whole transportation took much longer. Also, our pallet was selected by the Japanese customs for extra X-ray inspection that we had to pay, and in the end the pallet arrived just 3 days before we arrived to Japan by plane. So it was super tight, and there was no extra time where we could prepare something, so we had to make some guess what we need to take with us, pack it and take it with plane. We took 19 H tubes with us. The extra set of the tubes with Japanese characters was packed into a hand luggage, which I was planning to take with me on board to handle it carefully. And there was another full case of H tubes that were about to be in a checked bag. The question was if the security guys will allow me to go on board with the Nixie tubes. It's very weird looking object. So I wrote to the support of the airlines, they asked me what is inside, I described the Nixie tubes, I mentioned the neon, and they got back that it's absolutely prohibited to transport anything with compressed neon. So there is no compressed neon, of course, but I just gave up with the support, and I knew that I absolutely have not to mention the presence of the neon when I go through the security. In the end, the security guy was absolutely not interested in the Nixie tubes. He just stared at them for a couple of seconds and then let them go. So we had our extra Japanese characters safely on board. arrived to Hiroshima by Shinkansen train from Tokyo. We didn't have any time to inspect the packages. We just dropped them off at the museum because they were just closing. And then, completely tired, we went for an evening walk in the Nagarekawa district, which is a part of the Hiroshima city. It's a super exciting place for Europeans, so different to our cities. It's full of tiny restaurants, full of lights and other interesting stuff. Yesterday we arrived to Hiroshima after 26 hours on the way, and now we are going to museum to inspect the Nixie tubes, whether they survived. One of the things we couldn't bring with us to Japan was ethanol for cleaning the tubes. So in the morning we went to the city and found a store where we can buy one, and with a translation app we located the exact bottle that we would like to buy. But the problem was that the store was not yet open. It was open, we could get there, but it was opening in 1 hour. So at least we had a picture, and in the next store we could show the picture, and they sold us the bottle. So here is the museum. We are 5 minutes late, which equals to 10 hours in Japan. We are installing a work for Alfredo Jaar for museum. Like a name or name? My name?
いや担当というか
Yeah, so we'll see. In the museum we were greeted by Motoko, curator of the exhibition, and she took us to the place where we should install the Umashimenkana. We are completely blown away by the level of work that the museum did for this exhibition, because like a whole rooms were constructed out of plywood, very finely covered with a wallpaper and painted black, and yeah, the place was prepared so well. And we didn't even know yet if the tubes survived. It would be a complete humiliation if we unpack the boxes with the tubes and they would be damaged, or like we would not be able to put the installation together. So we started unpacking the pallet and inspecting the tubes. The good news was that there is no shattered glass nowhere in the boxes. But we quickly found a problem with few tubes in the check bag. 3 of them had broken welds, like the connecting wire to the stem. The weld was broken, which made the tubes unusable. Still 10 more lines remaining. So far we have these 6 victims of the transport. This is the space for the visitors where they will see the work. And we are installing it from behind. This is our space. So it's the second day of our installation. Yesterday we made 66 tubes and today remaining 55. So far we have some bad tubes, but if it goes in the same ratio as it was in yesterday, we should have enough tubes to complete the installation. It's just starting to rain, so go inside. Good morning.
Good morning, how are you?
Nice rain. Nice morning rain. Yeah. Yeah. But we will dry out during the work. As the installation progressed, there was more and more people stopping by to check how it goes, and I was more and more nervous because there was still a couple of boxes not inspected, and I was not sure that we will have enough tubes. Fortunately, the tubes in the last boxes were completely free of defects, so we could finish the installation, and we even had some 10 tubes as spares. The next step was to do the fine-tuning of the installation so that Alfredo Jaar is satisfied with how it looks. We did most of the work when the Umashimenkana was finished and installed on our wall in our workshop. But there is always a risk that the customer will want to make some modifications when he finally sees it on the place. For a couple of hours we were tuning the electronics, and it turned out that Radim is absolutely necessary because he knew everything about the software and the electronics, so he could implement the changes Alfredo wanted in a matter of minutes, test them, and then make additional modifications. And then finally came the time for the last test. As the lights dimmed, letting the Nexi tubes shine in the dark, we sat against the wall, gazing at Umashimenkana in all its glory. This moment was the most emotional for me. It marked the end of 3 years of work, now successfully delivered exactly as the customer envisioned. Plus, it also means I can finally send a final invoice and take a breather, relieving our exhausted budget. When we started working on this project, the atomic explosion in Hiroshima felt like a distant historical event to me, something like we can see only in TV documentaries. However, as we arrived in Hiroshima, I became to realize how relevant this topic still is to the people of Japan. It wasn't just about the hundreds of thousands of immediate victims, it extended also to the countless individuals who suffered health problems in the years that followed the explosion. At the exhibition's opening ceremony, an incredible moment occurred. Alfredo Jaar walked alongside a lady named Kazuko Kojima, who placed flowers at the memorial cenotaph. Kazuko Kojima is that baby born on that night after the Hiroshima nuclear bombing 77 years ago. That same night that inspired Sadako Kurihara to write Umashimenkana poem.